Welcome back from the break, grade 11s. Right, we are now going to use our reasoning and our words to answer this next question. So let's look at it. Explain why, so there's the explain why the boiling point increases from compound A to E. Now this kind of question could be worth 3 marks, it could be worth 4 marks. So we've got to put down all the facts and be quite clear about them. So if we look from down the table from A to E, we can see that the boiling point is increasing. It starts at negative 164 degrees Celsius and it ends therefore compound E at 343 degrees Celsius. So what is happening here? So in the beginning we discussed how if we look at these compounds that they're actually increasing in size, and that means that their molecular mass is going to increase as well. So an increase in molecular mass means that the intermolecular forces needs to increase as well. They're going to increase because of the increase in mass. With the intermolecular forces being that much bigger, more energy is needed to overcome those intermolecular forces, and that is why the boiling point is going to increase. So how are we going to write this in words? Well, we need to be very particular and we need to say the words that our examiners are looking for. So let's have a go at it. So this is what we're going to say. We're going to say, first of all, that there is an increase in molar mass or molecular mass, let's call it molecular mass. Can you see that? I hope you can see it. I'm going to move down to the next layer. So increase in molecular mass from compound A to E. Okay, so that's the first point. Okay, first point. Second point, what are we going to write? Because there's an increase in molecular mass, it means that there's going to be an increase in the intermolecular forces. So we're going to write that down. So there is an increase, therefore there is an increase in the strength of the intermolecular forces. Intermolecular forces. Now I know you're saying, do we have to write this out? Yes, you do. Yes, you do. Okay, so it's like history. You actually have to write everything out in this particular question. And we know we scientists don't like to write lots out, but for this question, yes, you do. Okay, so what does that mean? Well, it means that more energy is needed to overcome these intermolecular forces. So we're going to write, therefore, there's an increase of energy needed to overcome, yes, we're going to write it out again, the intermolecular forces. What is the last thing we're going to write? We're going to write, oops, it's not liking me. Okay, we're going to write that the boiling point is then going to increase. So therefore, the boiling point increases. Lovely. You're going to get all your marks for that one. Okay, let's move on to our next question. How does the vapor pressure of compound B compare to the vapor pressure of compound C? Okay, so here we've got B, so there's B, there is C, and it says write down only higher than, lower than, or equal to. So we're talking about compound B compared to compound C. Compound B compared to compound C. Compound B, you can see, has got a lower boiling point. That means that it is going to reach its boiling point quicker. And it means that there are going to be more particles in the gas phase than for C. So we're going to say that in this particular question, the vapor pressure for compound B is going to be higher than that of compound C, because there will be more gas molecules available to create that pressure, because they're going to bounce against whatever surface they're enclosed in. So there we go, that's that answer. Let's look now at this question, and this question involves a little bit of hydrogen bonding, so we can see what's happening with the boiling point with these particular substances. So we've got this table. There are three substances. We've got hydrogen sulfide, there it is there, hydrogen sulfide. We've got ammonia there, and we've got water. Now we know that from our previous discussions, we know that these two substances, their intermolecular forces, they will be hydrogen bonding. Okay, so hydrogen, that's what it's called, hydrogen bonding. Okay, so straight away, we'll know that their boiling points are going to be naturally higher, or their melting points. And we can see that. So we can see that ammonia is minus 33 degrees Celsius, and that water is 100 degrees Celsius. Hydrogen sulfide, this very first one, sulfur is not one of the most electronegative substances or elements that we have. So there won't be any hydrogen bonding in between those molecules. It says here, which one of the substances should be in the above table has the weakest forces between its molecules? Now, we've already spoken about that. If we don't know it, how can we tell? If we look at the boiling point, we can see that the boiling point is the lowest. It is the lowest in that table. That's negative 60 degrees Celsius. It needs to have the weakest forces. And so we would have to write the answer as H2S. So even if you had forgotten about the hydrogen bonding, you look at the boiling point. The lowest boiling point of a substance means that that substance is going to have the weakest forces between its molecules. Its intermolecular forces are going to be really weak because less energy is needed to overcome those intermolecular forces. Name the type of intermolecular force found between the ammonia molecules. So remember the ammonia molecules. Ammonia looks like this. Let's draw it out. So ammonia, there's an H, there's an H, and there's an H. It has got a lone pair on top of it, looks like that. And those hydrogen atoms that are bonded to the nitrogen, those electrons that are now shared, the bonding electrons, they are going to be pulled towards the nitrogen. Okay, because nitrogen is really electronegative, and so the cloud of electrons are going to sit over the nitrogen. The hydrogen is going to be an exposed proton, and so because of that, those molecules can get in really close. Their friendship is going to be strong, and so the intermolecular force is going to be hydrogen bonding. We're going to write it out like this, hydrogen, the whole thing, hydrogen bonding, because that is the name of the intermolecular force. Hydrogen bonding. Okay, what's our next question? Explain the following statement. Although the shape of the molecule H2S and water is similar, there is a remarkable difference in their boiling points. Have a look there. So that would make sense, right? It's almost the same formula. H2S, H2O, their shape is very similar. So we're looking at this, oxygen, and then a hydrogen, okay, and sulfur, and hydrogen, and hydrogen. What now? Why are their boiling points so unbelievably different? You already know the answer. The water molecules have an intermolecular force called hydrogen bonding, which is the strongest intermolecular force. The hydrogen sulfide is not, the sulfur is not a highly electronegative substance. Although it will pull the bonding electron pair towards itself, it's not so strong. So this molecule here is going to be a polar molecule for sure. Okay, polar molecule. This is going to be delta positive, that's going to be delta negative. However, it's not going to be as pronounced and so different as compared to the water. How are we going to write this down? Because we do need to write it in words. And so we're going to say that the hydrogen, we're going to name it. So the let's make that a capital, hydrogen bonding between the water molecules is much stronger than the dipole. Intermolecular forces, why do I need to say this? Because I want to tell the examiner I know what I'm talking about. Intermolecular forces between the hydrogen sulfide molecules. Right, grade 11s, I hope that has given you a good idea of how to put your understanding in words. I hope to see you next time. It is all for today.